Have you ever wondered why space is dark even though it's full of stars? It's a question that's been puzzling astronomers and philosophers for centuries. Here we are, on our little blue dot, surrounded by a black void peppered with twinkling points of light. You see, the cosmos is a vast expanse teeming with billions upon billions of stars. Each one is a radiant beacon, a celestial lighthouse casting its light into the universe. And yet when we gaze up into the night sky, we're met with darkness. Understanding this paradox starts with the basics of light. On Earth, when we see something, it's because light is bouncing off that object and into our eyes. Light travels in straight lines, and as it moves it spreads out and dissipates. So if there are billions of stars out there, why doesn't their light fill the sky? To answer this, we need to understand how vast the universe is and how stars are distributed within it. The universe is not a small or easy-to-fathom place. It's so massive that we often have to express its size in light years, the distance that light travels in 1 year, which is about 6 trillion miles. Now that's a number so large it's almost impossible for us to fully comprehend. When we gaze up at the night sky, we're not seeing the entire universe but merely our local neighborhood, the Milky Way galaxy, which is just one of the hundreds of billions of galaxies out there. Each of these galaxies is teeming with stars. Some estimates suggest there could be more than 100 billion stars in each galaxy. However, these stars aren't tightly packed together. They're actually incredibly distant from each other. To give you some perspective, our nearest star, Proxima Centauri, is a staggering 4.24 light-years away. That means the light we're seeing from that star right now actually left it more than 4 years ago. And Proxima Centauri is just our next-door neighbor in cosmic terms. There are stars out there that are billions of light-years away from us. The light from these distant stars is traveling across the universe to reach our eyes. But remember, light doesn't travel instantaneously. It has a speed limit, the speed of light, which is roughly 186,000 miles per second. So, the light from a star located a billion light-years away won't reach us for a billion years. This means that some of the stars we're seeing in the sky tonight might not even exist anymore. Their light is still en route to us, while others are so far away that their light hasn't reached us yet. And some stars will never be seen at all because their light will never reach us. Therefore, not all starlight has had the time to reach us, contributing to the darkness of space. Another factor to consider is the intensity of starlight. The brightness of a star is not a constant factor, it changes with distance, and this is all thanks to a principle known as the inverse square law. This law states that the intensity of an effect, such as light or gravity, changes in inverse proportion to the square of the distance from the source. Let's put this into simpler terms. Imagine a star as a tiny light bulb. When you're close to the bulb, it appears bright, right? But as you step back, it begins to look dimmer. This doesn't mean the light bulb is reducing its light output. The light is simply spreading out over a larger area and appears less concentrated to your eyes. This is exactly what happens with stars. The further away they are, the dimmer they appear to us. Now multiply this effect by the unimaginable distances between Earth and the stars. For many stars, we're talking about light years, a distance so vast that light, traveling at the speed of about 186,000 miles per second, takes years to reach us. The stars are still shining brightly, but their light gets dispersed over such a massive expanse that by the time it reaches us, it's faint, barely a whisper of its original intensity. So the vast distances between stars and Earth make many of them too faint for us to see, adding to the darkness. There's another piece to this puzzle, the absorption of light. Now let's picture a scenario. You're in a dusty room with a single beam of sunlight streaming through a window. You can see the path of light because the dust particles in the air scatter the light in all directions. This very phenomenon happens on a grander scale in our universe. The space between us and the stars isn't a perfect vacuum, it's filled with interstellar medium which is composed of gas and dust. When a star's light passes through this medium, some of it gets absorbed or scattered, just like the sunlight in our dusty room. The light that gets scattered is sent off in different directions, often away from our line of sight. The scattered light is essentially lost to us, contributing to the darkness we observe. The more dust and gas the light has to travel through, the more it gets scattered and the less of it reaches our eyes. Now imagine billions of stars, each sending out light that has to travel through light years of space filled with dust and gas. A significant portion of that light is absorbed or scattered before it ever reaches us. This absorption and scattering of light is a vital cog in the machinery that paints our night sky black. So the combination of vast distances, the finite speed of light, and absorption by dust and gas explains why space is dark. To sum up, the darkness of space isn't due to a lack of stars but rather a combination of factors. Let's take a quick journey back through our cosmic exploration. We began by contemplating the vast, almost incomprehensible expanse of the universe teeming with uncountable stars. Despite the sheer number of these celestial bodies, we learned that the finite speed of light plays a crucial role in shaping our perception. The inverse square law further complicates matters, diluting the intensity of starlight as it travels across the cosmic stage. Lastly, we discovered that not all light makes it to our eyes. Some of it gets absorbed or scattered, further contributing to the darkness. The cosmos is a complex masterpiece with layers of mysteries waiting to be unraveled. So next time you look up at the night sky, you'll know why it's not ablaze with the light of a billion stars. Don't forget to subscribe to our channel for more intriguing space mysteries unraveled.